All right, thank you for having me. So bacterial antimicrobial resistance is a fundamental threat to global health and safety. When we get infected with a bacterium, we need to take an antibiotic that needs to get inside of the bacterium in order to kill it. However, within the membrane of the bacteria, there are small molecular pumps called efflux pumps that are capable of throwing out many different types of antibiotics as soon as they are in. In a strain which I engineered not to have the pumps, we see that we need as little as 128 times less antibiotics to kill the bacteria. I have engineered another strain in which each individual efflux pump is emitting green fluorescent light, meaning that just by looking at how green whole cells are, I can deduce how many of the pumps they have and therefore how much resistance. When I look at the cells, I see that they are just a little bit green, which means that they are producing a few of the pumps. However, if I treat the cells which I engineer with an antibiotic, I see that they are getting a lot greener, which is absolutely remarkable and beautiful. It means that the cells are producing now a lot more of the pumps to help them cope with the stress of the antibiotic. I've therefore uncovered that bacteria have a volume button to tune up and down the production of these pumps. What I want to do now with that is find a new molecule, let's call it molecule X, that when added to the strain which I engineered would lead to little or no green fluorescence, meaning I will have effectively turned off the production of the pumps. We do this by screening large libraries of chemical compounds. In a plate like this that has 96 small wells in which bacteria are growing, you add a different compound in each individual well. The plate is then read by a machine that reads just how green each well is, and the whole process can be automated and done by a robot. So the ideal would be to have a pill that contains both an antibiotic and molecule X that would restore or improve the activity of the antibiotic, giving new life and new patent life to old antibiotics. At the same time, the technology could be licensed to bigger players in the pharmaceutical industry that could be interested in running such a screening by themselves. Currently, I'm applying for money from the Bundesministerium für Energie, and I'm closing a deal with a company in Hamburg that helps me run a screening like this on 20,000 molecules. What I haven't told you yet is that the same pumps are used by bacteria to secrete a molecule called enterobactin that is roaming around your body, scavenging iron and bringing it back to the bacteria. No iron, low virulence, bacteria cannot possibly infect. So this is therefore a double tap and a much needed silver bullet perhaps. Thank you.